So for our Math 326 presentation, we will be discussing factorable polynomials. To begin our presentation, we're going to start with this warm-up here. We have two exercises. The first one is x squared plus bx plus 10. The second is x squared plus 12x plus c, where c is greater than 0. We want the students to find the integers b and c that would make these polynomials factorable over the integers. Our hope is that this will get the students to start thinking about the AC method or the quadratic formula. After that, we're going to move on to this next activity. We're going to give them the polynomial ax squared plus bx plus c, where a, b, and c are integers from 1 to 3. And then we want them to determine what percentage of these polynomials can be factored over the integers. Our hope is that they'll just go ahead and use the brute force method and figure out the exact number. So they would list all 27 possible polynomials, determine which ones are factorable using either AC method or quadratic formula, and then however many are factorable, put that number over 27 to determine the percentage. After that, we're going to give them this next scenario, ax squared plus bx plus c, where a, b, and c are integers from 1 to 10. As you can see, this is a much larger set, so they will not be able to use the brute force method. So after they make their conjecture, we want them to use the Excel file that we provided, as you can see here. We have these two values. This is the range of integers. So we are dealing with integers from 1 to 10. So you can enter that, and then the computer will generate a random list of when this happens, or it'll pick random numbers for a, b, and c that are between 1 and 10, and then it'll calculate the approximate percentage of these 50 or so polynomials that are factorable. As you can see, though, because we only have 50 and not all 1,000 scenarios, the number will change as you continue to generate these lists. So we're hoping that the students notice that and then think about maybe why that does happen, and then how they could figure out the true percentage or maybe a more accurate approximate percent that are factorable. After that, our next activity is going to be to make a conjecture as to the percentage of these polynomials that can be factored over the rationals. After they make that conjecture, they're going to go and do the rationals tab of this Excel file. And again, they start at 1, then just go to 10, and then there's a list. And then they can continue to generate an approximate percent that are factorable. And then we can have a discussion about the differences between the approximate percents factorable or the similarities, and why they think that is the way that it is. Once we get through that, we're going to have this game of chance. So we're going to ask the students to go to a casino, and they're going to play this game where they bet, or where they choose from a list of polynomials, and they want to pick the ones that are factorable. And it costs them each $1 each time that they play, and they're going to play it 100 times. And we want to know how much would the house want the reward to be if the house wants the player to lose $40 each time, or each time that they play, if they play 100 times total. The first scenario is a, b, and c are integers from 1 to 20, and they're being factored over the integers. So the students will use the provided Excel file in the integers tab, and the integers range from 1 to 20. And then they'll get an approximate percent that are factorable. They'll continue to do that. And then once they zero in on a range or a number, then they could figure out what the house would want the winnings to be. And the same thing for rationals from 1 to 5. They'll figure out the percent. Basically, that's our percent of success rate. So here we get 8%. So if they play 100 times, they'll win 8 times, and then they'll want to figure out what the winnings are. Once we get through all of this, we are hoping that we have time for an assessment. We are going to use Poll Everywhere software. We're going to ask them 2 questions. we're going to ask them what was your initial conjecture, we're going to ask them if the initial conjecture was correct. Then we're going to ask them which values of b will make 3x squared plus bx plus 9 factorable over the integers. And that's just kind of going back to what we did at the beginning and using the different methods for factoring to solve that problem. When that's done, we're going to ask the students to complete this homework assignment where they determine the true percentage of polynomials that can be factored over the integers if the polynomial is in the form ax squared plus bx plus c, where a, b, and c are integers from 1 to 5. As you can see here, we've completed that, and the approximate percentage is 4.8.